Dear students, this is lecture 8. It's about developing project network, constructing the network using activity on node method. This is the most important lectures than before lectures. We are on the sixth block for our project management block diagram. Okay. What we mean about developing the project network? The project network is the tool used for planning, scheduling, and monitoring project progress. The network is developed from the information collected from the WBS, work breakdown structure, and it's a graphic flow of chart of the project job plan. The network depicts the project activities that must be completed, the logical sequences, the interdependencies of the activities to be completed, and in most cases the times for the activities to start and to finish, along with the longest path through the network, which we call it critical path. The network is the framework for the project information system that will be used by the project managers to make decisions concerning project time, cost, and performance. So, in short, the project network is the graphical means of the project. Means that if you translate the whole project plan, their output will be a diagram. We will talk about it later. The network will be built from the work packages. Project networks are developed from the WBS. The project network is a visual flow diagram of the sequence, interrelationships, and dependencies of all activities that must be accomplished to complete the project. The main component of the network is the activity. We can define activity as an element in the project that consumes time. Anything that consumes time, whether it's work or waiting. Even waiting for another activity to be finished is called activity. It's considered activity. Work packages from the WBS are used to build the activities found in the project network. Let's take an example. Here is a project for developing circuit board. We have elements. The elements are noted by the WB coding. For example, design has D11 specification, D12 documentation, production for the prototype number 1 and final prototype 2, testing the system T13-1, and for the software preliminary and software final version for the circuit board. Okay, this is not the network. On the right side, we have two types of networks. They are the same, but instead of using actual the work package name, we use the coding here. The project network is composed from two things: activities and arrows. The arrows represents the time flow from activity to another activity. Okay, let's go to the next slide. Here are some terms used in building projects. Activity. For project managers, an activity is an element for a project that requires time. It may or may not require resources. Okay. A considered to be an activity, B also another activity, C another activity, D, E, F, and K, they are all activities. Okay. There is a term called merge activity. This is an activity that has more than one activity immediately preceding it. More than one dependency arrow flowing to it. For example, here we have D. D is a merge activity. Why it's merge activity? Because there are two flowing arrows to it. This is called merge activity. which means D won't be start, will not be start until B and C both are finished. This activity that has more than one activity immediately preceding it. There is another term for activities, parallel activities. These are activities that can take place at the same time if the manager wishes. However, the manager may choose to have parallel activities not occur simultaneously. This is important. For example, here we have B, activity B, and activity C. They are parallel activities. If we wish to, we can start both at the same time when A is finished. We can't start with B, we can't start with C until A is finished. This is important. But a project manager should avoid multiple concurrent parallel activities. For example, if we have D and F parallel activities such as B and C, there will be some confusion. We all need to have single parallel activities, maybe 3 of them. It's possible, but concurrent parallel activities is not recommended. Okay, the third path is the sequence of connected dependent activities. For example, there are 2 paths here, path A, B, D, F, K, and there is another path A, C, D, F, K. There are 2 paths here. Good. Okay, there's a special term for paths. One path called critical path. When this term is used, it means that the path or paths, or critical path, there might be more than one critical path with the longest duration through the network. If an activity on the path is delayed, the whole project is delayed the same amount of the time. This is important term actually. Suppose that since we have 2 paths here, A, B, D, F, K, and A, C, D, F, K, suppose that A, B, D, F, K is the critical path. Why? Because B has longer time than C. So if we delay, C is delayed a little bit, but not exceeded B, it won't be a problem for the overall project because B will substitute it. In other words, if B has exceeded its own time, then the whole project will extend as well. Why? Because D wouldn't begin until B and C they both finish at this. Both should be finished. This is what we mean by critical path. We will take examples later. The term event. This term is used to represent a point in time when an activity is started or completed. It does not consume time. It's just like milestone. Okay, where is the events here? We have here the beginning or the end of A is an event. The beginning of B is an event. The beginning of K is an event. We have the third activity type, which is burst activity. The burst activity has more than one activity immediately flowing to it, more than one dependency arrow flowing from it. So which activities here are burst activity? We have only one burst activity. A is a burst activity. Why? Because there are 2 arrows flowing from it. To construct project network, we have 2 approaches to develop project networks. One is activity on node. We will discuss this in this term. And the another type is activity on arrow. We will leave that for reading purposes only. You will find out more about it in the next book. Both methods use 2 building blocks, the arrow and the node. Their name derived from the fact that the former uses node to depict an activity, while the second uses an arrow to depict an activity. As we can see here, this is activity on node. Why? Because all the information is on the node, and the arrow does not have any other information. By activity on arrow, the arrow will have the information, and the nodes, activity nodes, will not. This is the main difference between the two approaches. In practice, the activity on node AON method has come to dominate most projects. Okay, there are some basic rules to follow developing project networks. If you have a project specification, you can, and Word WBS for the whole project, you can develop the network, but you have to be careful. There are some guidelines to do that. Networks flow typically from left to right. An activity cannot begin until all preceding connected activities have been completed. Arrows on networks indicate precedence and flow. Arrows can cross over each other. Each activity should have a unique identification number. As example here, A is unique. A will not repeat it further anymore. An activity identification number must be larger than of any activities preceding it. Here we use alphabetic, so B, it should be followed by A, and D followed by B. K should be larger than F, because in the alphabet K would be after F, and so on. Looping is not allowed. In other words, recycling through a set of activities cannot take place. Or in other terms, arrows will not go backward. Never. If you draw an arrow in a network project, it should go from left to right. Any arrows that goes from right to left, it's wrong, because it can cause looping. Conditional statements are not allowed. This is type of statement should not appear. If this node is successful, then do something. If not, do nothing. Conditional is not allowed at all. Experience suggests that when there are multiple parts, a common starting points, multiple stars, a common starting point can be used to indicate a clear project beginning on the network. Similarly, a single project node can be used to indicate a clear ending. An activity is represented by a node box. So A is an activity, B is an activity, C is an activity. The dependencies among activities are depicted by arrows between the rectangle boxes on the activity on node approach. Those are the arrows. There are three basic relationships that must be established for activities, including in a project network. The relationships can be found by answering the following three questions. Which activities must be completed immediately before this activity? This is an important term. These activities are called predecessor activities. Activities must be completed immediately before this activity. Predecessor activities. Which activities must immediately follow this activity? These are called successor activities. Which activities can occur while this activity is taking place? This is called a concurrent or parallel relationship. Let's back to our types of activities. We said that we have merge activity, parallel activity, and burst activity. Okay. Here, X considered it as a burst activity. Why? Because there are two arrows coming from it and going to activities Y and Z. While M is considered as a merge activity because there are three elements or three activities flowing to it. Here we have two different things. We have both X and Y, they are both burst activities, while Z and AA, they are merge activities. We don't have parallel activities here, but you can say that X to Z, Y to Z are parallel activities.